Hello everyone, welcome back to Calculus 1. This time we are moving to section 4.5. It is another kind of derivative application. It's the topic of derivatives and how derivatives will dictate the shape of the graph. So section 4.5, derivatives and shapes. Derivatives and shapes. First of all, let's get some basic idea about the graphs and the derivatives. So I have, maybe four cases, really two cases. I want to know the solid blue curve. It's the graph of the function. And then those dotted lines, orange or yellow kind of dotted lines are supposed to be the tangent lines. And indeed, as I'm saying, two cases, because I do consider somewhat, well, speaking the type of the function, both are increasing functions. Okay, this curve and the other curve. And also, you look at both cases. Indeed, well, those dotted lines, they indicate the tangent lines. And remember for the tangent line, for a line, okay, when the slope it is positive, the line goes up. And you see the point over here, line goes up, line going up. The tangent line is going up, which means slope are positive. Slopes are positive in both cases. And similarly, in those cases here, for the second graph, slope is positive. So what I really want to say here is you may want to know, it's just true. When you know the derivative of the function is positive, and we simply can say the function must be increasing. Derivative is positive indicates the function is increasing. And for the two lower graphs, both are decreasing functions. And surprisingly, they decrease in different ways, right? But anyway, the surprising part here is that you look at the tangent line. Tangent lines, all the tangent lines, they are going downward. So it is just true. When you have the derivative as negative, the function is decreasing. Okay, I hope it's easy to remember. The derivative is positive, the function is increasing, like those two cases. The derivative is negative, which means the function is decreasing. And also, well, in general, given a function, you don't expect it to maybe increasing forever or decreasing forever. Some part is decreasing, some part is increasing. So hopefully this graph makes sense. In this part, the derivative is positive and the function is increasing. And this part, the graph goes lower, goes downward. So the function is decreasing. And also, we really can verify derivative is negative. Derivative positive again, and then turn to increasing, and actually keeps increasing. Look at this situation here, somewhat interesting, particularly at this point. We are still having a smooth curve. We're still having a smooth curve. It keeps increasing, but anyway, from here to there, you can tell it is a smooth transition, right, from this type of shape of curve, this shape of curve to the other shape of the curve. Still, together, they still form an increasing function. And we will have little more discussion about the shape, not only the increasing, decreasing, it's concavity I'm talking about. And also, simply put, I want to say concavity, it is determined by the second order derivative. But anyway, for now, we are just looking at the situation increasing and decreasing, hopefully easy to remember. And also, it is just true. Given a function, very likely at some point it is decreasing, and on the other intervals it might be decreasing, and it may go several rounds. Okay. So the next part, it is the formal statement on the textbook. First, the derivative test. And indeed, the derivative test, it is used to find out maximums and minimums. And still, you may want to know from the derivative test, from the first derivative test, really, we are talking about a local maximum and a local minimum here, okay? And kind of long, I think it might be easier if we just use the actual example, look at the situation. Basically, it is just true. Let me see if it's on this graph. Well, you see, at this point, somewhat this is kind of in a high position, right? derivative 0. At the point derivative 0, we have a maximum. That is a local maximum. At the point derivative 0, we also have a local minimum. And also, this is the point that derivative is equal to 0. But anyway, it's not maximum or minimum at all. Okay. But anyway, in general, the derivative is 0, indicates possibly we have a maximum or minimum. Okay. So let's look at the situation. It is to find out the local extrema for the function. Okay, find the local extrema for the function. This is a cubic polynomial, third degree polynomial. So as I said, basically for the local maximums and the minimums, they got to be found by using the first derivative test. So no doubt, this is what I did. I calculated the first order derivative. And then we understand, I suppose you figured out, usually the function may have a maximum or minimum, like we discussed in the previous section, at the point where derivative is 0. So we try to find out those critical points. And indeed, in this case, I hope easier to say, the derivative can be factored, and it can be factored into linear factors. So there are two critical points. The next part, I'm using this table, but anyway, it really should be helpful if you understand how I created this table. It is constructed using those critical points, -1 to the left, 3 to the right. Okay, imagine you really, it is from real number line, consider the very top of the edge of this side, that's a real number line. You have 2 points, x equals -1 and x equals 3. Clearly, if you understand what I'm saying, I suppose you're seeing 3 line segments. Each line segment, it is inequality. Okay, so the inequality for between -1 and 3, it represents a line segment in between. And then for any part to the right of the 3, it is for x greater than 3. And similarly, this is how I get x less than -1. Any point to the left of this -1. Okay, and then according to the critical points, you want to create a table. And I'm putting those 4 actual rows here. Okay, the first row, basically what I want to tell here is for each inequality, the table is kind of big, but anyway, I say x equals -1, x equals 3, as we already calculated here, right? Mostly, we just needed to figure out those inequalities. The first inequality, it is for x less than -1. You choosing x value less than -1. Could be -2, that's what I did. Or if you want, you can do -3, -4, or -10, really. Any value less than -1 would work. And then you want to check if derivative is positive or negative. Like on this table, what I figured out here is, well, look at the derivative. It would be easier using the factorization form, okay. I'm choosing something less than -1, -2. So this parenthesis, it's negative, right? And the second pair of parentheses, still negative. The product of 2 negatives is positive. So which we need, for any x less than -1, the derivative, it is positive. Derivative, it is positive. And then remember, derivative is positive simply means the function is increasing. Function is increasing. Okay. And then at x equals -1, not a lot to talk about. And we know the derivative is 0. Keep in mind the derivative is 0. At the point the derivative is 0, it could be maximum, could be minimum, and also could be neither. And I will explain a little bit why I decide this is maximum. Okay, in a moment. And then for the interval in between, x between -1 and 3, choose some easy value. So I would say 0 would be the easiest, right? Still, it might be helpful if you consider the factorization of the derivative. So the derivative, it is a product of a positive and a negative. Overall, it should be negative. Derivative is decreasing. Derivative is decreasing. Okay. Derivative is negative means the function is decreasing. And similarly, x equals 3 is a critical point, which really means derivative 0. and it could be maximum or minimum, and also I will explain in a moment why I got a minimum here. Okay. Then for the last inequality x greater than 3, you can choose 4 or 5 or well, what I did, just show some randomness. I just simply consider x as 10, which is for sure greater than 3. Then put this 10 back into the factorization of the derivative. I see derivative is positive, right? Because all the factors are positive. So derivative is positive. Derivative is positive, which means the function is increasing. And then, as I'm saying, if you're watching the video, try not to look at the two bottom lines. And what I'm trying to tell you here is the maximum and the minimum, local maximum and the minimum should be determined without checking the actual values. Because for the local maximum or minimum, indeed, the minimum could be bigger than the maximum. Okay. So I'll give a try to see if I can explain why I have max over here, local max. Because I look at the behavior of the function to the left of this x equals -1, x less than -1, right? The function is going up. And then to the right, the function is going down. So in my mind, I am visualizing, I am seeing the point at x equals -1, somewhat it is at a higher position, at a high position. So accordingly, I'm seeing the function value as a local maximum. It is indeed a local maximum. Okay. Similarly, at x equals 3, well, to the left, now this part is to the left, it is decreasing, and then to the right, it is increasing. So I'm seeing x equals 3, the point at x equals 3 must be sitting somewhere in a lower place, So accordingly, the function value must be a local minimum. So I put a local minimum here. And anyway, I did a calculation. F of -1, that's 4. F of 3 is -20. Okay. And indeed, 4, it is the local maximum, and -28, it is a local minimum. There is a local maximum and a local minimum here. Okay. And this is how the graph would look like. And also, look at our calculation. I'll just say this function, it is a function of third degree, right? Cubic polynomial. In general, it is just hard to figure out the graph. And indeed, even without knowing the graph, we somewhat get some very good information about the function, the local maximum and the local minimum. And then combine some other information, we could draw this graph by hand. Really, we could draw this graph by hand. So this is, of course, first part of the discussion from section 4.5, derivatives and graphs. At this moment, I'm saying you must know when the derivative is positive, the function is increasing. The derivative is negative, the function is decreasing. At the point derivative is 0, it could be a maximum, it could be a minimum, or could be neither. Okay. And that should be it for now. Thank you for watching. I'll see you next time.